Nice to see you all again. Yes, let's get going. I am behind the 3D stuff, and I have been working on it for a couple of years already, and it's way too fun. And I must say APL is highly functional for this task, although usually you believe that it's C++ and compiled languages. It surprises me. But before that, I need to stop answering these questions individually, so I give an answer to everyone here right now. The thing is, you take a Suzuki, it's a very fast bike, and you take a parking lot, and then someone adds oil, and the speed doesn't need to be high, only 15 kilometers an hour, and you go there and the bike disappears. That's how it functions. It's very simple equation, and the result, A plus B, is yeah, 6 ribs. The doctor said it's all gone on the left side. Anyway, so this is what happened, but it's better each day, so it only hurts when I laugh. So yeah. Stormwind Simulator, the single one product we have that I have been working on for a long time. I will go through not too much in detail. We don't have much time, and I try to give an overview. The voice is good. Thanks. The state, the goals, multiplayer. I'll show some action. I'll talk about the motion platform and challenge. Something happens. Yeah. But before that, yeah, I have to mention about APL. We all know where we are, and I just think it's a hugely luxury situation for us to be the users. We are a few in the world, and we can consider us lucky to have been the ones who happened to make this discovery. And the thing is, we are all quite smart. And I think it's a luxury. All since Iverson started up till today, I have been able to deal with people who are probably the most intelligent in the world. And that's no bullshit. There aren't too many above us. So we are really a bit of special. And I think everyone here should appreciate that. It's something, a bit of extra in life. So thank you to Dyalog. For my part, you are doing a great job, and you are thinking a lot. And you are producing amazing solutions all the time. Each time there is something, it's something amazing. And that's just fantastic. The simulator, it's tiny, amazing. We have 651 bytes of code. Well, it's like fits on a floppy. Yeah, what? Yeah, a half density, not even a full density floppy, a half density floppy. And 22,000 lines. Of course, there is data. There is 4 gigabytes of data. But that's not code, that's data. And we have been able to sell a few of these so far, only in Finland. It's been in hands, in tight hands. We haven't let it out intentionally because it's not quite ready yet. We want to do a few more things. But what we do have is authorities. You know maybe that Finland has a huge archipelago. Lots of islands and lots of traffic, lots of boaters going back and forth. Things happening. Additionally, we have the Russians who transport, I think, over 100 tankers each day going back and forth. And it's a potential for lots of accidents and events. So the rescue departments have an obligation to be able to come and help. There is no one after these guys. There is no one else. So they want to learn. Also, the military has been interested in and using for education. The marine. Is one of the biggest organizations for search and rescue in Finland, with representation in every city. And then we have a couple of science centers taking visitors. And the biggest customer segment is, of course, private households, people who want to learn and use a computer program. The price, the product itself, it's, well, I think I have it in my pocket, but I can't get it right now, but it's on a USB stick. Of some reasons, we use a piece of hardware, and one of the good reasons is that the USB sticks we use have an individual serial number, so it's a dongle. And also it's not so stupid, because if you want to give a gift to your husband for Christmas, what the hell, he has everything. He doesn't need more ties, and so buy a simulator and you can put some paper cover around it, and oh, it's just damn expensive. Good, Merry Christmas. Yeah. Anyway, the price is here, and for the professional users, the authorities, you can place 10 behind and take it thanks to. Yeah. The goals, most importantly now, it's single player. It's an application where you drive alone together with artificial intelligence, and we want to enable a common world where people can sit in different countries and cities and see each other, like in a multiplayer environment. A so-called massively online MMO, they call it. We want to enlarge the geodata to cover more than the USB stick. 3 main goals. The multiplayer architecture, I have no time to go into depth with how it actually works, but we will have one root server, game servers, not too many of them, but they are kind of control servers, and we will have clients, hopefully a huge number of them, who will talk to each other. The intense communication will be over UDP packets. The physics data will be over peer-to-peer connections. The other alternative is to have a game server who is authoritative, and all data goes through it and it makes all decisions. But this is for critical FPS games where it's very important that the guy who shoots first doesn't die, and it's about microseconds. We have time, and nothing is hugely time critical here. So we hope to be able to release ourselves from the burden of having limitations. By peer-to-peer, there is an option to make it huge, and that's how we are going to do it. And the game servers will be kind of commanding servers, doing part of the job only. Yeah. A little bit about, I have been talking with Björn about UDP packets. He's there. And in a gaming environment, you don't use TCPIP. TCPIP is a guaranteed communication. You establish a communication between two endpoints, and you say, send this to B, and the system ensures that it gets there. It resends, it slows down, it counts the order of packets and blah, 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 and it's a good solution for transporting data, and probably the best for the overall throughput. If you want to move much data, use TCP/IP. But there is latency. If you want to move small data quickly, you use UDP packets, which are, by nature, you kick them out to the world with an address and you forget them. You never hear from them again, and you don't know whether they got delivered or not, unless your logic contains functionality for resending an answer. And Windows provides, this is functions in Windows.net, and we use Windows sockets. It's a bit hard to explain without showing, and I think I will not be showing you any code. But the system is that you create a socket. Then you have something they call socket async event args objects. You can see there. And that's a Windows object, a .NET object, where you can fill it with data, you can fill it with the name of a callback function, and you can have many of these objects, so you maintain a pool of them. And each time you tell a socket to send out the UDP packet, you you grab one from the pool ASIC object and enter its data, say, send it out. So let's forget about this boring networking stuff. I'll show you if I get to the APL. Here it rough. This one. Font. What, sorry, what did you say?
Make it larger.
Larger. Okay, why? Because I'm going to start the application. Let's see now. Okay, you can see some GUI here. This is the root server, and I'm only showing a couple of things here. We do have a GUI for the server. And the window here is one that resolves all interfaces in this computer, or in any computer it runs in. And we have, you can see here, local IPs. They all start with 169, except the Loopback interface here. And one of them is actually the public connection to the outer world. And Windows reports that it has a gateway saying 192.168.13.1. And then the hotel does not allow me to connect to what is my IP. What is my IP is a site that reports your IP address, and it's the only way actually to know what your public IP address is, by connecting to a place who tells you what he sees. You cannot do it from the inside. And it unfortunately does not function, but anyway, I'll create a socket. And I'll show you what now happens. You can see in the window to right how the UDP packets go out, and unfortunately they do not come in this time. They came in an hour ago, but it tries to synchronize time. It connects to a time server, actually 4 time servers, and prepares UDP packets, small packets, like I think 48 bytes or so, and sends them and tries to get an answer back from the time server saying what time it is. And this is one of the very first steps. Yeah, no replies. So this is actually the reason I decided at some point that I won't try to show any networking stuff, because you can't set up a server in a hotel and expect it to work. I had wished that it would have allowed me to grab the time, because what you can actually, if you need to synchronize time, you can quite easily connect to time servers and get an accuracy of about 1 microsecond, which is rather good, and it's a matter of taking a number of samples with APL and then doing a linear best fit among all the samples you get, and calculate what you have at the moment, and you get the clock drift and the time at the moment. And this is essential for time servers. But let's skip this one and instead load the other one here. And this is the simulator. It's a bit dark. Let's set something else here. Here. Okay. This is one of the startup situations, and I have a menu. I press escape and get this one. I'm very happy with it. It's my own design, and it's very simple to use. You just place the mouse over the items here, and you can select other items here. And I need to remind you that it is APL who runs this all time. We do have a 3D engine between DirectX, the Windows graphics API, and the APL code talking to the 3D engine over .NET. But it's APL who, despite that, does all the work. It's in a big loop running through several thousands of lines of APL code in like 0.02 seconds, I think. So APL is truly speedy. It's surprisingly fast. Here you can select scenarios. You can select the number of boats here. Here is the Swedish combat boat 90. And a fishing vessel here. Interestingly, you can, we have a number of quick selections here. For example, tomorrow at noon, or to sunrise, midsummer, sunset -1, sunset +1. And you can see how it updates directly. Also, we have something called winter here. Now it's a very hot winter day. Yeah. No, not everything goes by automation. But here is the winter scenario, so it's what you see. It looks freezing. We can take a sea chart. We have 4 series at the moment and plan to make relevant enlargements. But this is the Finnish south coast, and you can see maybe a red ring here at this point. This is where we are at the moment. Helsinki is here. And yep. So I select this sea chart, and I can change the transparency of it a little. This is where we are. This chart, this paper is about 400 square kilometers. Yeah. And we also have a radar simulator, which is rather cool. It's good. It's the 7th generation inside Stormwind, I think. Sounds good. It's quite a professional one. So the guys from Marine and Furuno always, when we are at the boat exhibition, they sneakily appear, and I find them looking at the radar simulator, kind of interested. So we do have ARPA ACE features here. We recognize ships and can change a couple of things. It's not hugely advanced, but like, for example, head up, north up by pressing a key here. I'll disconnect that and go out for a while, and then I'll show you the stuff I borrowed from Jason. He was kind enough to carry with him hugely technological items. He's a freak, as you may know. He just... No, it was John who bought the television. Like, yeah, so it wasn't Jason, but anyway. We have a program here that is called controllers.exe. And let's minimize that. And this is how we connect wheels and so on in Windows. This is APL, and I should now have, yes, I have one item here saying Scitech something, and I decided I use that for steering function. I'll try to, I haven't tested this before, so this is entirely new for me, but I want this function connected to the steering of a boat. So now it provides a number of axes, and I need to walk through them because I don't know which one it is. So I select NAP. Could it have been this one? Okay, so you can see that when I turn it to right, it moves. And it's relevant that I go through the entire from edge to edge because I do the calibration in code at the same time. These controllers that practically every one of you have been using are quite smart because they return a number between 0 and 10,000 to the application. No matter if it's a steering wheel or a pedal or an Xbox slider, it's always 0 to 10,000. And it's easy for the coder to go on from that point on by rescaling the numbers. And let's see now. I also have another piece of JSON software here. Here, so it's a gas handle. And so I'll try to find that too. Could it be slider 0, for example? No, not really. Slider 1. No. Okay, let's try rotation X. No. Y. No, it's not that either. Z. That was bad luck. Y. If I don't find it, we don't necessarily. Well, here is. Right. So ahead. Well, it's up, and then I can find there's somewhere here in between. I want to have neutral. It's like at between at around 8,000. So I say 7,500. I can because these they behave a bit differently. So I have the option to feed in a number where I want the neutral to actually happen. So let's place here 8,500. Right, this way. And press OK. I can allocate all the buttons to different functions like map on, off, radar on, off, and so on. And then I need to find APL again. Holy. This. And LX. Now I should have these connected to Stormwind. And let's see. Oh yeah, functions. Yeah, so you can see the RPM. Well, I push this ahead, it changes, and then I need to make some steering here. Oh yeah, fine, this is great. Yeah. So in the middle, or actually it is here, the rudder angle. So if I push it to left now, I get to -40. That's the maximum, and to right I get to +40, and this is cool stuff. Yeah, it feels good. Yeah, I like it. And full speed. All right. I'll show you one more thing I like with this. First of all, let's go to another place. Just like with a little bit more of waves. I just press the center mouse button onto a location, and it takes us there. Here I can do a little bit of weather changes, and I'll show you just what happens. You have the summer heat. Oh, we need to select sunset, for example. Yeah. Morning fog, we can configure all weathers, but we have fast selections here. Unstable here. Limited visibility, breeze under, it gets blue. Bad weather, fresh weather. Oh, we should actually move a little bit more out to get the bigger waves, because they are always impressive. We go here. All right. And storm, a violent storm, of course, and a violent thunderstorm. These are more like nice to have. They are not really useful for anything. But that's what people want to see. So anyway, now I'll round up this actual simulator with showing a feature which I like very much. It's about the artificial intelligence. So we are now, where are we? We are here. And Helsinki is here. So we are close to the city of Hangö. And I now tell the simulator to take me to Helsinki by selecting position, and then I know Helsinki is one of the alternatives here. And what happens now is that it calculates it calculates the using the A-star pathfinding algorithm, a path to the destination, and begins to drive there. And you can see here how it actually, well, we could have taken a little bit trickier. Let's see now if we have some place where he actually needs to do something, like going here. Yeah, this is good. And then I say go to Helsinki. No, go to Helsinki. Right. And follow, radar on, and there. So it now needs to slow down, because this is a place where my good friend got a speeding ticket with boat, and he was very proud of it, because his boat is so fast that he actually got a speeding ticket. So yeah, it's a bit, it's deciding to do something. I don't know what it sometimes. Okay. I think it lost its orientation. But let's see if it stabilizes. Yeah. Yeah, well, this is real life. This is how they do. But now it decided that it's going to behave, hopefully. And it says that remaining distance 56.1 nautical miles, and traveling time 1 hour 32 minutes to Helsinki. And this is quite relaxing. This is not, I can't transport the feeling of this to you now, but I like it very much. You can just sit and watch how it takes you through the archipelago. And you don't need to focus and take responsibility and so on, so it's very convenient. Anyway, time is running out, so I will stop this and show the last things of... you have seen this machine from hell outside, and it's a motion platform, a hexapod, consisting of, it has 6 degrees of freedom. You imagine 3 triangles in a circle, and on top of that, a seat. And it's a Brazilian guy who contacted me quite some time ago, Leandro Tercete, in Sao Paulo. He is the one who is planning, constructing, engineering. Then we have the 2 Irish guys, now present, Magic Konopski. He is the SimHire Corporation owner, and his engineer Konrad Govacki. Also, we have a local Scottish guy who has been making the low-level software for the platform, Ian Hopper, and I hope to see him here in a short moment. I had made the simulator software, and of course everything is Morten's fault, because it was he who called me in the summer and asked, "Hey, can we do something funny? It's no problem." And I say, "Yes!" Right. And from Optimo Systems, Paul has been enabling by funding a bit of the items here, and he has been very interested in. He was actually the first one to. He enforced himself on top of the platform, and he would have been there still unless I had told the Magic to remove him from that. Right, and you will have an option to drive tomorrow, and you will have an option to maybe to try it today. For a couple of minutes you just sit there and you may drive anywhere. Magic will be showing you how to use it. You need the seatbelt on. We made a decision to, so there is no discussion. You take the seatbelt on and that's it. Because it moves quite heavily. There is lots of action. Tomorrow you will be starting from a location here, number 1, and your task is to drive and help your friend whose boat is burning at point number 2. And the problem is all these angry, you may have heard about this, well, I shouldn't mention, I say it once, Angry Birds. But it has nothing to do with this. Only birds let eggs, and we have angry eggs. I don't know where they come from, but they are very annoying, and they will be annoying with you too tomorrow. They attack you, and your goal is to drive from 1 to 2 and try to do it as fast as possible without getting taken by these creatures. And you will get the score, and there will apparently be a winner, which Dyalog will present later on. That's about what I know about this. Thank you. I'm ready now, so.